So we have point A. Now we are going to do the example for different hemispheres, south and north. So point A is 20 degrees south, 24:30 west, and B is 35 north, 120 degrees, 30 minutes east. So from south we are going to north, so this is north direction, and from west we are going to east. So D long here is 145 degrees. We need to add because different directions, west and east, and it's less than 180, so no need to subtract from 360. So our B point is northeast of A, so we first mark equator because different hemisphere, and then we mark A, which is south 20 degree, and then point B is 35 degrees north. Point B is somewhere up, so direction is east, so north is somewhere here, 35 degrees north. So the curve we have seen in previous videos, that the great circle curve in southern hemisphere towards south pole and northern hemisphere toward north pole. So suppose this is the pole. Now we can join these 2 points, this like this. So we get PA, PB and our diagram. Now this is 20 degree and this is from pole to equator 90. So PA is equals to 90 plus 20, that is 110 degrees. Then PB, equator to B is 35. So 90 minus 35 is equals to 55 degrees. So we have PB, we have PA, and we have angle P, that is our D long, that is 145 degrees. We need to calculate AB distance. So same cosine formula we will use. Cos of AB is equals to cosine of adjacent sides, that is cos of 110 and cos of 55, plus sine of adjacent sides, that is sine 110 and sine 55 degrees, and cos of angle P, that is opposite angle, that is 145 degrees. So with this we get the value of AB from the calculator. So with the calc we get cos AB is equals to 8745.78. Then we need to calculate cos A. For cos A, we need cos of angle. So the formula of cosine formula cos P is equal to cos PA cos AB plus sine PA sine AB cos A. So we get cos A and we replace all the values. Cos PB is 55. So this is our formula, cos P minus cos PA cos AB upon sine PA sine AB, and we put the values and we put in the calculator and we get the cos A angle A. So we get 56 degrees 37 from angle A, and the naming we do from the diagram. So you can see it is northeast measured from the north pole. So it's 056 degrees only our course. Now we will calculate angle B. So again cos B is equals to cos of opposite side minus cos of adjacent side upon sine of adjacent sides. So same thing we put in the calc and we get the values. So angle B we get 73 degrees 20.1 minutes. Now we resolve it into our course. So ship is somewhat going like this. So we get this 73 degrees 20 minutes. So our course will be from north to this. So we subtract from 180 and we will get our course west. So north 73 20.1 minute west will be 180. So that to get our final course, 180 minus 73.20. So that is, we put in the calculator. So we get 106.39.9 west. 39.9 west. So it's quite simple. Same, we calculated distance, initial and final course, and that we will write as the answer. So now we are going to do great circle questions with intermediate points. So we have a departure position A and a arrival position B, and we have to find the great circle distance, initial course, final course, and then the position of the vertex using Napier's rules, and then longitude for the intermediate point, intermediate latitude 30 degrees north, and latitude for the intermediate point for longitude 175 degrees east. So one is in southern hemisphere or one is in northern hemisphere, like our previous questions. And A is 3351 south, and B is 3747 122 30 west. A is in south and B is in north. So we always determine the pole by the body of the higher latitude. So B is of higher latitude, so we will take North Pole. So previously also we have seen that when southern latitudes we take uh, when southern latitude is higher, we take southern latitude, southern pole. Now longitude is very close, and so like from Greenwich meridian, east longitude is on right side and west longitude is on west side. And this is anti-meridian, that is 180 degrees. So on the other side of the earth. So west longitude will be on the west side and east on the east side, but it will be on different direction. But on left side we will have east, and right side we'll have west, and reducing the, we have also a separate video for that if you are not. So like it's coming from 0 to 180, so it will be in this direction east, and then 0 to 180 westerly will be like this. So directions and figures of will be increasing like this up to 180, 0 to 180. So 151 east will be on the east side and 122 on the west side. So this is the D long or range between these longitudes. So I think it's clear if you, even if you are watching first time. So we plot the position and make the diagrams. We draw North Pole and we have A and B and we have the equator. And first we have to find sine PB and PA. So we have B 3747. So 90 minus 3747 is PB, that is 52 degrees 13 minutes. And then we need to find PA. So P to equator is 90 and equator to A is 3351. So 90 plus 3351 is 123.31. So we found we have PB and PA. We need these values for finding the distance and all our values. So be very sure of your calculations. In southern, we are adding to 90 if it is from North Pole. So making of diagram is very important. So for D long, we know the rule that east and west is in different side. We add them, and if it is same side, we subtract them. And if it is more than 180, then we subtract from 360. So we can see here is more than 180. So we subtract from 360 and we get 86.14 and we reverse the direction. So as we can see from 151 to 120, we are going to east. So the D long sign will change to east. So from east to west, when we are going, we get westerly D long and we subtract from 360. So we get easterly. Now we need to find cos AB, that is our great circle distance. So we know the cosine formula cos P is equals to cos AB minus cos PA cos PB upon sin PA sin PB. So we get cos AB and we calculate from the scientific calculator after putting in all the values. So AB is equals to 107.35 degrees. That is our great circle distance. So we multiply by 60, we get 6440.8 nautical miles in the in nautical miles. So that is our great circle distance. So now we need to find cos A, that is initial course. So again, we put in the cosine formula and we got A is equals to 55.7 degrees. So now we need to determine the quadrant. So to determine the quadrant, we need to go to the diagram and also it should be matching the answers. It should be matching with this. And then we go to the diagram to determine. So we can see from the diagram it's northeast. So north we have to round up to 56. So see the diagram, you can see the, if it is more than 90 then it would be in the second quadrant, but here you can see it's measuring from north pole, so it is 056 degrees true course. So sometimes it might go to southeast as per the diagrams, but now we have northeast. So our true initial course is 056 degrees true. We have to round it off, remember. We can steer in degrees or maximum 0.5. Then we will find the final course, that is cos B. So again, putting the cosine formula, cos of opposite side minus cos of adjacent sides upon sine of adjacent sides. We put in the values and we get cos B is 109.7 degrees and we round off. So we get 120 degrees. Now we need to find the quadrant. So from the diagram, we will find out that we need to subtract 180 because we got this angle B, that is 120, and we need to find the outer angle, that will be our course. So we subtract from 180 and that will be our final course, that is 060 degrees. So north 060 degrees, so 060 degrees 2 is our final course. So for finding the vertex, the rule of thumb is initial and final course are the same quarter, then vertex will lie outside A and B. And if initial and final chords are in same quadrant, then vertex will lie within the diagram. So we need to find the vertex, that is the highest latitude of this course of great circle. So because our initial and final chords are in the same quadrant, so vertex is lying outside, so we make a vertex outside. And because it is on the rising side, B is on the rising side, so that is where we will make the vertex. So PA, PB we know, we will solve this from Napier's rules. So V is equals to 90 degree always, that is the vertex. So Napier's rule is always used when it is a right angle triangle. We have a right angle. So if you don't know Napier's rules, we have a separate video, you can watch that. So we have a triangle or angle PAV. So AV and PV, 90 minus A, 90 minus P, and 90 minus PA. So we know A, now we know PA. So we know 90 minus PA. PV we need to find out, that is our vortex. And 90 minus P is the longitude of the vertex. So the thing in Napier's rule is if you know two things, you can find all other things. So either here you can use triangle PAV or you can also use PBV. Why PBV? Because we know PB and we know angle B. So if you know any two things, you can use any triangle. But here we are using PAV. So for making the Napier's rule diagram, we put V is equals to 90 and then the adjacent sides, that is AV and PV, and then opposite angles, 90 minus A and 90 minus P, and then opposite side, 90 minus opposite side is 90 minus PA. And what do we know? We know angle A and we know PA, that is 90 minus PA. What we need to find? We need to find out the latitude and longitude of the vortex, that is we need to find PV, and then we can do 90 minus PV will get the latitude, and we need 90 minus P, that is angle P. If we get, we'll subtract from the initial d long and we'll get the longitude of the uh, vortex. So let's find out. So we are using the Napier's rule here for sine of middle part is equals to cos of adjacent parts. So you can see sine PV, cos of opposite parts. So sine PV is equals to cos 90 minus A and cos 90 minus PA. So to find PV, we have A and we have 90 minus PA, so we can find PV. And so one point we already learned in trigonometry, that cos 90 minus A is equals to sine of A. So sine PV is equals to sine A sine PA, and we put the values and we get the value of PV. So we got PV and we need to find out the latitude. So from 0 to V, that is latitude of V, that is 90 minus PV, that is 46 degrees, 40.8 is the latitude of V or the vertex. That's what we got. So we found out the vertex by Napier's rules and the latitude of the vertex. Now we need to find out the longitude of the vertex. That is, we use sine of middle part is equals to. So that's why it's a big question and we are doing separately. So we always use the parts we know like A and PA. So 90 minus P and 90 minus A is the adjacent sides. So sine of middle part is equals to tan of adjacent parts. So sine 90 minus PA is equals to cos PA, trigonometry rule. And we just put the values and we get angle P 129.2 is 129 degrees 14 minutes. So we know the longitude of A is 151 degrees 16 minutes, and D long we got 129 degrees. So P is angle B, is this angle that is from D long of longitude of A to longitude of E, that is angle P. So to get the longitude of the vertex, that is longitude of A is 151 16 minutes east, D long is 129 14 minutes east. So longitude of V is 79 degrees 30 minutes west. So we add them and then subtract from 180. So we can make this diagram 180, and A is on the left side 151 and V is on the right side, and this way we can easily solve to get the longitude of V. So we have to find the coordinates of intermediate points now. So we are given longitude 175 degrees east, and then next point we are given n, which is 30 degrees north. So we need to find the latitude of m and longitude of n. So same, we use Napier's rules, and we take PVN triangle where vortex is equals to 90 degree. So Pn will be 90 minus 30, that is 60 degrees. So we know Pn, we know PV. So you know PV, you know two things. You can use Napier's rules, and we basically need to find out the longitude, that is angle P. That is, we need to find 90 minus P. So sine 90 minus P is equals to tan of adjacent sides, that is PV and Pn. We replace the values and we get angle P 57 0.8 minutes west, and then longitude of V. So we know longitude of V was 79 degrees 30 minutes west, and D long we got as 57 degrees 0.8 minutes west. So longitude of N or north is 136 degrees 30.8 minutes west. So again we can make, so from west we are going more west, that's why we added. You can again make a diagram 180 degrees in between and going from 79 to 15 degrees more west. So we got 136 degrees 30.8 minutes west. Then similarly, next triangle PVN. So our longitude was given 175. We need to find out the latitude, and it's very close to anti-meridian, that is 180 degrees. So in this case, D long between V and M, we subtract. So we need the D long between V and M. This is 7930 west minus 175 east. So our D long is 105 30 minutes west. That is our angle P. So we have PV, we have P, and we need to find out PM, that is our latitude. So sine 90 minus P middle parts equals to tan of adjacent parts. So sine 90 minus P is equals to tan PV, tan 90 minus PM. And putting the values, we find out PM. So we got PM 105.8 degrees, and we subtract from 90. So we get 15.8 or 1549. So it's more than 90. So it's in southern direction. So we put 15 degrees south is our latitude. So I hope everything is clear. If any questions further, you can ask. We will continue with some more typical examples. So stay tuned and don't forget to subscribe, like, share, and comment.